For section 4.3, we're going to be looking at applications of systems of equations. In other words, we're going to be looking at solving some word problems using systems of equations and multiple variables. All right, for our first application, we're going to be looking at two word problems. And for our first one, we're going to be talking about some hockey tickets and basketball tickets. So it was reported in 2004 that 2 hockey tickets and 1 basketball ticket would be about $126.77. It was also reported that 1 hockey ticket and 2 basketball tickets would be $128.86. What were the average ticket prices of the 2 sports? Well, the very first thing that you're going to want to do is look at what it's asking you to find, because those are going to be your 2 variables that you're going to have to establish. So it says, what are the average ticket prices for the 2 sports? So the 2 sports are hockey and basketball. So in this case, I think what I'm going to do is I think I'm going to have my H stand for my hockey tickets, and I'm going to go ahead and have a B stand for my basketball tickets. Once you've established your 2 variables, you have to establish 2 equations with those 2 variables. Remember, if there's 2 separate variables, there's got to be 2 separate equations. Well, if I look back up at my problem, I notice right here that it says 2 hockey tickets and 1 basketball ticket is $126.77. So 2 hockey tickets would be 2H, since H represents hockey tickets, plus that 1 basketball ticket, or O capital B, equals $126.77. So it looks like I've got my first equation just by looking at that sentence. If you look at the following sentence, it says 1 hockey ticket and 2 basketball tickets are $128.86. So now we've got only 1 hockey ticket but 2 basketball tickets, and that's $128.86. Once you've got your equations set up, what you're going to want to do is decide whether you want to solve by elimination or substitution. Now this problem looks like an elimination problem because it's set up H's above H's, B's above B's, and constants above constants. Now what I'm going to go ahead and do is I'm going to take this second equation and I'm going to multiply everything by a -2. And what that's going to allow me to do is cancel my H's. So if I multiply everything in that second equation by a -2, I'm going to get a -2H, a -4B, and a -257.72. Once I've multiplied, I'm going to eliminate that middle equation. I've already manipulated it to what I want, and I'm going to go ahead and add down. My H's are going to cancel. I'm going to be left with 3B equals -130.95. And if I divide that -3 over, I get a basketball ticket equals $43.65. That actually sounds like a reasonable answer. Now you guys are well aware that that's only part of my answer. I still need to find out how much a hockey ticket counts for. So what we're going to do is we're going to take that capital B and we're going to plug it into that top equation over there. I'm going to come over here where I've got a little bit more room. 2H, we don't know what H is, plus B. Well, instead of B, I'm actually just going to put in a $43.65 since I know that that's what basketball tickets are costing. And then I'm going to go ahead and solve backwards. So once I minus that over and I divide by the 2, I end up getting that hockey tickets cost $41.56. So I have basketball tickets costing on average $43 and hockey tickets on average costing $41. And I've solved this system of equations. For our final word problem, I want to go ahead and look at a mixture problem. Now in Unit 2, we worked with mixture problems a lot, and we used that graphic organizer to help us organize all of our information. We're going to do the same thing here. The question says, how many ounces of a 5% and how many ounces of a 20% has to be combined to get 10 ounces of a 12.5%? If you remember from that graph that we drew way back in Unit 2, you'll remember that this is the how much column times the rate column equals the equal column. You'll also remember that below this bottom line is our idyllic percentage, or our idyllic rate. When we worked on these mixture problems back in Unit 2, I said always fill out the rate column first. So it looks like we've got a 5% hydrochloric acid solution, we've got a 20% hydrochloric acid solution, and our idyllic rate, or the rate we want to get, is a 12.5 hydrochloric acid solution. And you know that because it says I want to get a 12.5. So you know the 12.5 has to go on the bottom. The second thing that we talked about in class was doing the how much column. So how much of the 5% solution? Well, we don't know. It says it right here. How many ounces of a 5%? How many ounces of a 20%? Once again, we don't know. How many ounces of a 20%? We don't know. Now, I'm going to label those two different variables. I'm going to label one X, and I'm going to label one Y. I have no information on how much of each of those I'm going to use, so I need to use two separate variables on that. I do know that I want exactly 10 ounces of the 12.5% solution, so I know to carry my 10 down right there. Now from here, we're going to go ahead and multiply across and get this column. And if you'll remember from Unit 2, this column ends up being the equation that we have to solve. So it looks like I get a 0.05x right up here, a 0.2y here, and a 1.25 here if I multiply that across. So I've got the equation of 0.05x plus 0.2y equals 1.25. Now this is great. I've got an equation, but I've got an equation with two separate variables, and that's not okay. When we have two separate variables, we have to have two separate equations. So where am I going to get another equation? Well, if you look at this column, we've got this column as well. We know that of the two solutions, we want to get 10 ounces total, giving us our second equation of x plus y equals 10. Now I'm going to flip to the next slide to solve this because I'm running out of room. Now I need to go ahead and solve for both of my quantities. So I'm not going to do elimination here because I don't want to multiply by decimal. I'm actually going to do substitution. And to do substitution, the first thing I've got to do is get one of these variables by itself. So I'm going to minus that y over and get the x by itself. Once I get the x by itself, I'm going to take that and I'm going to plug it in for x into that first equation. So instead of 0.05 times x, I'm going to have 0.05 times 10 minus y. Plus 0.2y equals 1.25. So the first thing I'm going to do is distribute that 0.05 in, giving me 0.5 minus 0.05y plus 0.2y equals 1.25. Now I'm going to go ahead and put my y's together since they're like terms, and in the same step I'm going to minus that 0.5 over to put my numbers together. So I'm going to put my variables together and I'm going to put my constants together at the same time. This is going to get me 0.15y. This is going to get me 0.75. And when I divide that 0.15 over, I get y is 5. So I know I need 5 ounces of the 20% solution. How do I find out how much of the other solution? Well, you actually just take the y that you just solved for and you plug it straight back into there. So in x, instead of 10 minus y, is 10 minus 5, which happens to be 5. So my answer is 5 of the 20% solution and 5 at the 5% solution. And that would be my answer to that word problem.